Format problems today are part of the notes here. So assuming you can see the problems, go ahead, pause the video. I want everybody to work on those problems, put down your best answer, and then once ready, push play, and we'll discuss the solutions. So when taking a look at inequalities, when we're determining if an inequality is true or false, the way I was always taught was that for an inequality, we are looking at this thing being an alligator and the alligator eats the bigger thing. So if we're trying to determine if this is true or false, we want to know if 4 is bigger than the 5. 4 is not bigger than 5, therefore this is a false statement. Number 2, notice the alligator is eating the 10. 10 is indeed bigger than 3. This is a true statement. Number 3 says -2 is greater than 4. Remember that positive numbers are always bigger than negative numbers. -2 is not bigger than the 4. That is false. When comparing two negative numbers, remember the more negative it is, the smaller. So if we were to look at the number line, so we've got 0, and then we go up 1, 2, 3 from 0, and then we go down from 0. That's going to be -1, -2, -3, and so on. Notice -5 is right here, -9 is right here. -5 is bigger than -9. This is saying -9 is the bigger one. This is a false statement. -12 is more negative than -6. -12 would be over here somewhere. -6 is right here. -6 is the bigger one, which is what this inequality is saying. This is true. -12 is greater than -20. -20 would be further to the left than -12. This is also a true statement. Again, negative numbers, the more negative they are, the smaller they are. In today's notes, we will be writing inequalities and graphing inequalities. I guess we should switch that around because we're going to be graphing them first. We will start by graphing inequalities, and then we will be given a graph, and we will be trying to write the inequality. Starting off with some vocabulary. The first is a solution of an inequality. We have previously defined the solution of an equation. Remember, equations have equal signs. Inequalities have less than or greater than, less than or equal to, or greater than or equal to signs. The solution of an inequality is any number that makes that inequality true. Not today, but starting soon, we will be trying to find all solutions to the inequality. Equivalent inequalities are two inequalities with the same solution. Equivalent inequalities have the same solution. Our inequality symbols, there are 4 of them that you should recognize. The first one looks like this, and that is the less than or inequality. This one is greater than. Notice the first thing is bigger than, greater than the second thing. Less than or equal to, greater than or equal to. So the little symbol under it is the or equal to part of the inequality. When we graph inequalities on a number line, sometimes we will use what is called an open circle, and sometimes we will use a closed circle. An open circle, that's just a circle that is not shaded in. And we use an open circle if the number itself is not part of the solution. So open circle means that that number is not colored in, it's not part of the solution, which means we use it if we don't have the or equal to part of the inequality. We only use it for the less than or the greater than. We also have a closed circle. A closed circle is the colored in one. We use that if the number itself is part of the solution. Therefore, we will use that for a less than or equal to, or a greater than or equal to symbol. So example 1 asks us to graph each of the following inequalities. Graph each of the following inequalities. And the first one we are given says A is less than 5. So we are graphing A is less than 5. So when we go to our number line, we need to make sure that 5 is on there. So go ahead, sketch in a number line. I'd put 5 somewhere in the middle. We should label at least a couple points on each side. I'm going to count up by 1, 6, 7, 8. And down by 1s, 4, 3, 2. We need to decide if we have an open circle or a closed circle. A is less than, but not equal to 5. A should not be equal to 5. I do not want 5 to be shaded in because it is not part of my solution. So I put an open circle at the 5. And then there's a few different ways that we can figure out which way to shade. The first is to read your inequality. We are always trying to shade in the variable. So this is saying A is less than 5. In this case, the 5 is bigger than what I'm trying to shade in. If 5 is bigger than what I'm trying to shade in, I need to shade in all this over here. That is one way we can figure out which direction we should shade in. Make sure you put a big arrow at that end as well to show that that shading continues on forever. So that's the first way we can figure out which way to shade, is to read the inequality. The 5's bigger. I'm trying to shade in that variable, in this case A. So if 5 is bigger than my shading, I need to shade to the left. Another way we can figure out which way to shade is to use a test value. Pick any value somewhere on the number line. I'm going to go with 2. Put it in for A. That would say 2 is less than 5. Decide if that is a true statement or a false statement. 2 is indeed less than 5. That's true. So I want to shade in 2, which means I need to shade in this side over here. Same answer that I got previously. Suppose that I had picked 6 instead of 2. If I plug in 6, now it says 6 is less than 5. 6 is less than 5. That's false. So I don't want to shade in 6. 6 is on the right side, which again tells me to shade in left. So the first way we can tell which way to shade is to read the inequality. A is less than 5 tells me this way. The second way is to pick a test point. You can pick any test point. Don't pick 5. All that tells you is that you should have an open circle. But pick any value other than 5 should tell you which way to shade. And then the third way, and I only mention it because I think a lot of students have heard this, and it only works if the variable comes first. So in this case, the variable is first. If the variable is first, I can draw this inequality symbol into an arrow, and that arrow is going to point the direction that you should shade. Again, that is only true if the variable comes first. If the variable does not come first, this is not correct. I would recommend one of the first two ways on understanding which way to shade. But if you remember this, and you can remember to only do this if the variable comes first, notice that arrow is pointing to the left, which again tells me to shade left. So no matter which way we're doing it, our final answer should look like that. Part B. Part B, we are asked to graph the inequality C is greater than -2. I'm going to keep working off of the same number line. I would recommend you draw a new number line. C is greater than -2. We label our number line. When you have negative numbers, be careful. I put -2 on there. As I get bigger than -2, the next number should be -1. I'm getting closer to 0, and then 0, and then 1, and then 2. As I get smaller than -2, we've got -3, -4, -5. Again, we have an open circle. The reason for that is I do not have the or equal to symbol there. Open circle at -2. I am trying to shade in the variable, in this case C. C, my shading is bigger than -2, which tells me to shade in this way. If you prefer one of the other methods to determine which way to shade, that is fine. Part C. We're given 4 is greater than or equal to m. 4 needs to be on there. So 5, 6, 7 as I get bigger, 3, 2, 1 as you get smaller. Hopefully we can recognize that because of the or equal to symbol, m could be equal to 4. So I want to include 4 in my shading. I show that by using a closed circle. If we think through which one's bigger here, 4 is bigger than the variable. The variable is what I'm shading. 4 is bigger than the shading. So if 4 is bigger than the shading should be in this direction. Notice if we tried a test point, if I had plugged in 3, let's say 4 is greater than or equal to 3, that is a true statement. I would want to shade in 3. If you're going with the arrow method, that arrow method only works if the variable comes first. So I could rewrite this with the variable first. Notice the 4 is bigger. So when I rewrite it, the 4 still needs to be bigger. And now if you draw that arrow in, it does point to the left, which is the way that we should shade. I want you to try these 3. You get each of these 3. 3 is less than or equal to b. -4 is less than x. And y is greater, -6 is greater than y. So again, pause the video, you try each of those. Once you have them, you can push play and see the solutions. Double check your numbering. Should start at 3 and get bigger, get smaller, close circle. My b is bigger than 3. My shading is bigger than 3. Should be this direction. -4 is less than x. -4 needs to be on there. Double check your numbering. -3, -2, -1 as we get bigger. -5, -6, -7 as we get smaller. Should be an open circle. X is bigger than the -4. Shading goes this way. And the last one, got -6 on there. Should be an open circle at -6 and shaded in this direction. My -6 is bigger than the y, so my shading needs to be to the left of -6. That is graphing inequalities. Let's take a look at how to write inequalities. So we're really using the same properties, it's just kind of backwards. They are giving us the graph, and we will be writing the inequality. So the one on the left here, notice we're working with 0, so let's call our variable x. We know it's 0. We want to think, is the shading smaller than the 0 or above the 0? In this case, it is smaller than the 0. The 0 is bigger than the shading, so that should look like this. Because it is a closed circle, we need the or equal to. X is less than or equal to 0. This one, notice my open circle's in between 0 and -2, so that would be -1. Notice the shading is bigger than the -1 this time. I need my shading to be bigger than the number. It's an open circle, so I do not include the or equal to. Here we've got -5. My shading is bigger than the -5 and also equal to the -5. Between 4 and 6 is 5. My shading is smaller, but not equal to. That is all for today's notes.